Good day everyone and welcome to our General Mathematics class. I am Shirley and for today's discussion, we will be having graph of a rational function. Let's start. Okay, so in graphing a rational function, we have different elements to consider. These are the asymptotes, the intercepts, zeros, and the dominant range. So these elements will give us an idea of how the graph of the rational function will behave. So magkakaroon tayo ng idea kung paano ang magiging itsura ng ating graph sa ating Cartesian plane pagka ginraph na natin siya. Okay, so isa-isahin natin sila. So the first one is the asymptote. Pag sinabi nating asymptote, this is a line that the graph approaches but never intersects or crosses it. So ito daw yung linya kung saan yung ating graph ay papalapit ng papalapit pero hindi sila magko-cross sa isa't isa. So meron tayong dalawang uri ng asymptote. The first one is the vertical asymptote. So ito yung nakapatayo asymptote. On the other hand, a horizontal asymptote naman, of course, is yung ating asymptote na nakapahiga. So, paano natin makukuha ang vertical at horizontal asymptote? For the vertical asymptote, this can be obtained by solving the value of x in the denominator of a rational function. So, sa ating vertical asymptote pala, we are just going to check our denominator. On the other hand, ang horizontal asymptote naman can be obtained by comparing the degree of the numerator denoted by letter n with the degree of the denominator denoted by letter d. So ano ba yung sinasabi nating degree of the numerator and degree of the denominator? So pag sinabi nating degree, that is the highest exponent that appears in any term in a given expression. So in other words, ito daw yung pinakamataas na exponent na makikita natin sa ating expression. In this case, dahil lang sabi niya, degree of the numerator n and degree of the denominator d, ang titingnan natin dyan ay yung degree sa ating numerator at denominator. So, let's say for example, we have x squared plus 5x plus 6 all over x plus 3. So, kung ang kukuhanin natin ay yung value ng ating n, that is the highest exponent na makikita natin sa ating numerator. In this case, ang highest exponent natin ay 2. So, ang degree ng ating numerator denoted by n ay 2. On the other hand, if we're going to find the value of t, which is sabi dyan, the degree of the denominator, titingin tayo sa ating denominator. So, kung makikita natin, ang highest exponent na meron tayo sa denominator ay 1. Alam naman natin na kapag ang exponent ay 1, hindi na natin siya sinusulat. But, if you will see a term like this na walang naka-indicate na exponent, it is understood to be 1. Okay? So, in this case, the value of n is 2 and the value of d is 1. So, ano yung mga conditions after nating makompare yung degree ng numerator at degree ng ating denominator? So, una, if n is less than d, then the horizontal asymptote is y is equal to 0. Okay? So, kung mas mababa daw yung value ng n kesa sa value ng d, automatically, ang horizontal asymptote natin ay y is equal to 0. Second one, if the value of n is equal to the value of d, then y is the ratio of the leading coefficient of the numerator and the leading coefficient of the denominator. So, ano ba yung mga sinasabi natin na leading coefficient? Ang leading coefficient, ito yung number or numerical coefficient nung term with the highest exponent. So, let's say for example, we have x squared plus 5x plus 6. So, ang leading coefficient natin dito ay yung number or numerical coefficient ng ating term with the highest exponent. So, ang term natin with the highest exponent dito ay yung x squared. So, ano ba ang numerical coefficient ng x squared? So, alam naman natin, kapag kaganyan, if we will not see any indicated number here sa unahan, that is understood to be 1. So, ang ating numerical coefficient dito ay 1. Third one, if n is greater than d, o kung mas malaki yung value ng n kaysa sa value ng ating d, then there is no horizontal asymptote. Wala tayong horizontal asymptote for the given rational function. Let us have an example para mas maintindihan natin. So let's say that we have this function y is equal to x plus 1 all over x minus 2. Let us first find the vertical asymptote. So, based on our discussion, the vertical asymptote can be obtained by getting the x value of our denominator. So, looking at our denominator, we have x minus 2. So, for x minus 2, if we are going to get the value of x, we are going to equate this to 0. So, solving for x, we will be having x is equal to, we will have negative 2 to the other side of the equation, and that will be equal to 2. So, therefore, our vertical asymptote is x is equal to 2. Second one, we have the horizontal asymptote. So, for the horizontal asymptote, sabi doon, we're going to compare the degree of our numerator and the degree of our denominator. So, as you can see here, our numerator is x plus 1. So, the highest exponent that we can have here is, of course, this one, x raised to the first power. So, the degree of the numerator, denoted by n, will be equal to 1. Same with our denominator, the highest exponent that we can see here is 1. So, therefore, for this one, the value of d is also equal to 1. So, based on these values na nakuha natin, we are going to follow the second condition, wherein sabi doon, if the value of n is equal to the value of d, we are going to get the ratio of the leading coefficients. So, ang leading coefficients natin, sabi natin kanina, yun yung number or numerical value na kasama ng ating term na may pinakamataas na exponent. In this case, sa numerator natin, we have this one, that is our leading term. So, ang numerical coefficient niya will be 1. At the same time, for our denominator, which is also x, ang ating numerical coefficient, which is also our leading coefficient, is also 1. So, sabi dito, we're going to get the ratio. So, that will be 1 divided by 1. That will be equal to 1. So, therefore, our horizontal asymptote will be y is equal to 1. So, we have here the following values. Vertical asymptote, x is equal to 2. And the horizontal asymptote, which is y is equal to 1. So, paano natin siya ipapakita sa ating Cartesian plane? So, for our vertical asymptote, sabi kanina, ang vertical asymptote natin will be x is equal to 2. So, if we're going to plot, that will be this one. So, it is a vertical line that passes through the point 2, 0. On the other hand, for our horizontal asymptote, based on our solution kanina, that will be y is equal to 1. So, where is positive 1 in our Cartesian plane? So, for the y-axis, that will be there. So, our horizontal asymptote is the horizontal line that passes through the point 0, 1. Okay, so that will be our first element. Next, let us have the intercepts. For the intercepts, this refers to any given point of the curve which intersects the axis or axes. Okay? So we have two intercepts that we're going to solve. So we have the first one, the x-intercept, and the second one, the y-intercept. So for the x-intercept, it is the point where the graph of a function intersects the x-axis. So this can be obtained by setting y is equal to 0. On the other hand, the y-intercept naman is the point where the graph of the function intersects, of course, the y-axis. And this can be obtained by setting x is equal to 0. Okay, so let us use the same example that we have kanina. So let's say we have this given function again, y is equal to x plus 1 all over x minus 2. Let us first solve for the x-intercept. Again, to solve for the x-intercept, we are going to set y to 0. To do that, we will be having 0 is equal to x plus 1 all over x minus 2. To eliminate our denominator, which is x minus 2, we are going to multiply both sides of the equation by x minus 2. So we're having x minus 2. So for doing that, we will be having here also x minus 2. So we can have x minus 2 cancelled here. And then of course, x minus 2 multiplied to 0, that will be equal to 0. So 0 is equal to x plus 1. Solving this further, if we're going to have positive 1 to the other side of the equation, it will become negative 1 is equal to x. Or we can say that x is equal to negative 1. This now will be our x-intercept. On the other hand, if we're going to solve for the y-intercept, we are going to set x to 0. So doing that, we will have y, capital variable, is equal to, replace all x with 0. So you will have 0 plus 1 all over 0 minus 2. Simplifying this further, we will have 1 over negative 2, or we can say that y is equal to negative 1/2. This now will be our y-intercept. So if you're going to plot them to our Cartesian plane, okay, so it will look like this. So we use the same Cartesian plane wherein nailagay na natin kanina yung ating vertical asymptote at horizontal asymptote. So based on the values that we obtained, we have our x-intercept, which is equal to negative 1, and our y-intercept, which is equal to negative 1/2. So sabi natin, ang x-intercept, yun yung point kung saan dadaan yung ating graph sa x-axis. So if x is equal to negative 1, the point will be found here. Okay? So at the same time, pag sinabi naman natin y-intercept, iyon yung point kung saan dadaan ang ating graph sa ating y-axis. So dahil ang value na nakuha natin kanina is y is equal to negative 1/2, if we're going to check our y-axis and then locate negative 1/2, that will be here. Okay? So those will be our intercepts. The intercepts of our rational function. Okay, so next element will be the 0 or zeros of the function. So yung 0 of the function is also known as the x-intercepts or the solutions of the functions. So dahil meron tayo dito, x-intercept, it is also known as the x-intercept of the function, we already obtained the x-intercept dun sa ating solution kanina. So dun sa ating solution kanina, we have the x-intercept as x is equal to negative 1. So that value of x-intercept will be at the same time the zero of our function. So if we're going to check our Cartesian plane and locate our x-intercept, also known as the zeros of the function, it will be located here. Okay, so that will be the zero of our function. Okay, next, we have the domain and range. So in our previous discussion, we already have an idea of what is a domain and a range. When we say domain, these are the input values, or also known as the x values. On the other hand, when we say range, these are the output values or the y values. So remember that if we are going to state the domain and the range, we need to consider the restrictions. So for rational functions such as this one of the restrictions that we need to consider is the division by 0. So we know that any number or any variable divided by 0 is undefined. So ito yung kailangan nating i-consider if we're going to state the domain and range of a given rational function. Okay, so let us make use of the same function y is equal to x plus 1 all over x minus 2. So let us identify the domain and range of this function. So based on the equation of the asymptote that we obtained a while ago, so we know that the vertical asymptote is x is equal to 2 and the horizontal asymptote is y is equal to 1. So based on this, we can say that the domain of our function is any real number except 2. Or in set notation, this is written as x such that x is an element of R. X should not be equal to 2. At the same time, the range of our function is any real number except at y is equal to 1. Or in set notation, that will be y such that y is an element of R. Y should not be equal to 1. So as you can see, we base our restrictions on the asymptotes that we obtained a while ago. Okay? Because the asymptotes, as we know, will be the values at which the function is undefined. Okay? So, aside from that, let us try to identify some points on the graph of f of x by completing this table of values here. So, as you can see, on our table of values, we included negative integers like negative 2 and negative 1. We also included 0, as well as positive values 1 and 3. So, to get the value of y, we're going to substitute those values to our function. Upon doing that, we will also come up with ordered pairs that we can plot to our Cartesian plane. Okay? So, first we have if x is equal to negative 2. So, using the function that we have, y is equal to x plus 1 all over x minus 2. So, what we're going to do is we're going to substitute, of course, negative 2 to our function. So, negative 2 plus 1 all over negative 2 minus 2. So, simplifying this further, we will have negative 1 over negative 4, and that will give us positive 1/4. Therefore, at x is equal to negative 2, y will be equal to positive 1/4 or 1 over 4. Next, let us have another value. Let's say, for example, we have if x is equal to negative 1 naman. So, y is equal to x plus 1 all over x minus 2. That will be negative 1 plus 1 all over negative 1 minus 2. So with this one, we will have, of course, negative 1 plus 1 will be 0 over negative 1 minus 2 will be negative 3. But we know that any 0 divided by any number will be equal to 0. So with that, we can say that the value of the function at negative 1 will be 0. Another one, if we have if x is equal to 0 naman. So again, using the same function, y is equal to x plus 1 all over x minus 2, we will have 0 plus 1 over 0 minus 2, and that will give us 1 over negative 2, and that will be equal to negative 1/2. So that will be the value of our function. So negative 1/2 at x is equal to 0. So if we're going to do the same, we will come up with negative 2 at x is equal to 1 and positive 4 at x is equal to 3. So we know that for this table of values, as I said earlier, each pair will correspond to a point in our Cartesian plane. So let us try to plot those ordered pairs. Okay? So let's do this. So we have here the table of values from our solution a while ago. So let us plot each ordered pair. First point, we have negative 2, 1/4. So if we're going to locate it in our Cartesian plane, so hanapin natin, that will be this point. Okay, so for the second point, we have negative 1 and 0. So as you can see, negative 1, 0 is already marked in our Cartesian plane. Since negative 1, 0 is our x-intercept na pinlat na natin kanina. Next, we have 0, negative 1/2. So for 0, negative 1/2, just like negative 1, 0, is already marked in our Cartesian plane. Because this time, 0, negative 1/2 is our y-intercept. Continuing, we have 1, negative 2. So, if we're going to locate that, it will be this point. Okay? And then, for the last point, we have 3, 4. Ayon. So, it will be on that area. So, the next thing that we're going to do here is we're going to sketch the graph of our function by connecting these points. So, okay, so if we're going to connect these points, that will look like this one. So, after that, of course, we're going to consider these broken lines here. So, sabi natin kanina, those are the asymptotes of the graph. So, with that one, that will be yung line na i-approach ng ating graph, pero hindi siya mag-intersect. So, doing that, it will be like that. And then, on the other side, it will be also extended in this direction. Okay? And then, for this point here, so, we may have this one. So, if we're going to find more points, we will see that the behavior of the graph will be like this. So, this will be going up there, going to positive infinity, and then this will be going to positive infinity also for the x values. Okay? Okay, so let us try to check our answer using a graphing software. So, we have here, ayan. So, using Desmos, we have here the graph of our rational function, x plus 1 all over x minus 2. So we can see here the vertical asymptote passing through the point 2, 0. And then we also have the horizontal asymptote passing through 0, 1. At the same time, we can also see here the points. Ayan, so we have those different points. And then, of course, the x-intercept. We also have the y-intercept. And we also added some points for us to clearly see the behavior of our graph. Okay? And that completes the graph of our rational function. So that ends our discussion. Thank you very much for watching and hope to see you again in our next video.